Hi class, in this video we are going to find a position vector. So in this example we are going to take a vector that is represented with Cartesian coordinates with an initial point P1 and a terminal point P2, and we are going to take that and make a position vector out of it. And usually we use our position vectors in the form V equals x something times I plus a y coordinate times j. Now, given our initial point and our terminal point, we find those x and y values by taking x2 minus x1, and that gives us our x position, and then y2 minus y1 will give us the y position of our position vector. So let's try this as an example. So let v be our vector from the point P1 equals negative 1, 3 to P2 equals 2, 7. And I want to write v in terms of I and j. And remember, I and j are what we call our unit vectors. Okay, and I is the vector that is 1 unit on the x-axis, and j is the vector that is 1 positive unit up on the y-axis. Okay, so let's find our position vector. So we see here from our formula just above that my position vector is going to be x2 minus x1, and that's going to give us our I. So x2 is 2, or no, yeah, x2 is 2, and then x1 is negative 1. So 2 minus a negative 1, I, and then plus our y position is going to be y2 minus y1, and y2 is 7, and y1 is 3, so 7 minus 3j. So now I just have to simplify. So I have 2 minus a negative 1. Well, those two negatives come together to make a positive, and 2 plus 1 is 3, so my position vector becomes 3i plus, and then 7 minus 3 is 4, so 3i plus 4j. And you can also use this with this notation here. So 4. All right, and that is how you go from 2 points to a position vector. What this is going to do for us is make adding and subtracting and scaling vectors together much easier without needing to graph them.